This is section 1.4, functions given by words. Table of values from words. Okay, by words we mean it's described to you either as a word problem or as an actual mathematical description of a formula. So making a table of values from words is common with exponential growth and decay. We'll actually look at exponential growth and decay later on in chapter 4 in more detail. Okay, so for now we just want to be able to make the table of values and verify that the values do in fact match a given formula. We will give you the formula. You won't have to come up with it. In chapter 4, when we look at this in a little more detail, you will then have to actually come up with the formula on your calculator. So some examples of this. A drug in the bloodstream deteriorates so that at the end of each hour only 75% of the original amount remains in the bloodstream. If we start with 96 milliliters of the drug at time t equals 0, and Q of t denotes the quantity of the drug in the bloodstream at time t hours after the drug is injected, create a table of values that gives the amount of the drug in the bloodstream from t equals 0, 1, 2, 3, and 4. If necessary, round your answers to 3 places to the right of the decimal point. Use a table to verify that f of t, which is given by 96 times 0.075 raised to the t power, models Q of t by calculating f of t for the values t equals 0, 1, 2, 3, and 4. So we're just going to see that do the table, the values in the table match when we plug in the values of t equals 0, 1, 2, 3, 4 into this function. Do they match? So since I have to make those calculations on the calculator, and we're going to have to do it several times, let's go ahead and enter that function into our calculator. So let's put it in y1. So I've got 96, open parenthesis, 0.75, close parenthesis, whoops, close parenthesis, raised to the t power. It's going to put an x, but it doesn't matter. Okay, so let's quit that screen. Okay, so we're going to be evaluating that function for the values of 0, 1, 2, 3, and 4. So our solution to this problem. So we're going to make a table of values starting with t equals 0. Q of t is going to be 96, okay, for t equals 0 because that's what we started with, right, 96. And we calculate f of t. We multiply each value by 0.75 to get the next value for Q of t on our table because that's what it says. At the end of each hour, only 75% of the original amount remains in the bloodstream. In word problems, the word of almost always means multiply, especially after it's a percent. So here's going to be my table, values of t, Q of t, and f of t. Just so you can see that f of 0 is also 96. We take out our calculator here. So vars, y vars, function, it's y1 of 0, and is in fact 96. So far, they're matching. Okay, if t is 1, 0.75 times the previous value of 96, so 0.75 times 96 really is 72. And to verify that f of t is, or excuse me, f of 1 is 96, again we take out our calculator, just do second, enter, replace the 0 with a 1, and it is 72. Okay, let's go, since we have the calculator out, let's go ahead and calculate y of 2. Okay, y of 2 is in fact 54. Okay, so let's see what happens here in our table. What did I do? I want to get out of that. So let's go back here. Okay, when t is 2, I want to have 0.75 times that previous value. So 0.75 times 72 is 54, and we already showed that f of 2 is 54. Now when t is 3, we're going to have 0.75 times 54, and that's 40.5. Okay, in our calculator, let's verify that in fact y of 3 is also 40.5. It is. And we do have one last value to calculate for t equals 4. So let's go ahead and do that now in the calculator. So f of 4 is 30.375. Let's see what happens here. We're going to do 0.75, excuse me, 0.75 times 40.5. It is in fact 30.375. So our function our function f of t equals 96 times 0.75 raised to the t power does in fact agree with Q of t, at least for t equals 0, 1, 2, 3, and 4. Example number 2. The amount of money in an account is growing at a rate of 3% per year. So you're getting an extra 3% at the end of each year. if the account initially had $10,000 and A of t gives the total amount of money in the account at the end of t years, make a table of values for A of t for t equals 0, 1, 2, 3, and 4. And if f of t is equal to 1,000 times 1.03 raised to the t power, evaluate f of t at the same values of t to verify that f models A. Round your final answer to the nearest whole cent if necessary. Since this is money, nearest whole cent, which is 2 decimal places, does in fact make sense. So let's go ahead and key in f of t into our calculator. So let me clear all that stuff out. Let's clear out that value of y1. I'm going to have 10,000, open parenthesis, 1.03, close parenthesis, raised to the t power. Let's get out of that. Let's quit that screen. And since we're supposed to round to the nearest whole cent, and that's 2 decimal places, let's go ahead and set our mode float to 2. Okay, so we're all set up. Now we are going to have to calculate f of t for t equals 0. Let's go ahead and do that now. So vars, y vars, function y1 of 0. It is in fact $10,000, which is what we started with. So our solution. Okay, so we make the table of values starting with t equals 0, and A of 0 is going to be 10,000, right? Because that's what we started with. And we calculate f of t, which we just did. To get the new value of A of t, we had the current value of A of t to 0.03 times the current value of A of t. That should say add, not had. Okay, because remember, we're increasing 3% each time. So what we started with times 0.03 added to that. Okay? So values of t, A of t, and f of t. Now we already did all the stuff for t equals 0. Now if t is equal to 1, okay, we're going to have 10,000, what we started with before, plus 0.03 times 10,000, we get $10,300. Okay, you can actually verify that on your calculator. Now to verify that this is in fact what it's supposed to be, from f of t, so second, enter, change the 0 to a 1. Okay, we get 10,300. Remember, I set my float to 2, that's why I'm seeing the 0.00. And I'm going to have to do it for t equal 2, so let's go ahead and do that now. We get $10,609 for f of 3, excuse me, f of 2. Let's see what happens when I do the table. Okay, just so you can see what's happening here. I'm going to have 10,300 plus 0.03 times 10,300. Notice they do in fact agree. So that's what happens on this row. Okay. Now for t being 3, okay, for t being 3, let's go ahead and do the 10,609 plus 0.03 times 10,609, and that's what A of t is going to be, $10,927.27. Let's verify what f3 is. So I got to go to vars, y vars, function y1 of 3. Oops, close parenthesis. And they agree. So that's what happens in the row with t being 3. Okay, we have one more row to go. Let's go ahead and do the f of 4. So second, enter, f of 4, $11,255.09. If I do the A of t, it's supposed to be $10,927.27 plus 0.03 times that amount. So times $10,927.27. They agree. So there's the row for 4. So I had to go down here to get it all up there because my number of digits started getting rather large. So f of t, which is given by that 10,000 times 1.03 to the t power does in fact agree with a of t, at least for values of 0, 1, 2, 3, and 4. So again, in Chapter 4, we will learn how to calculate or make the calculator find the function for us that does in fact model the description in words. Okay, functions from words. There are a few standard business functions that we're going to look at. Okay, most of them involve the idea of money. So some of you that are business majors or banking and finance majors might actually know this already. Okay, now remember, money is naturally 2 places to the right of the decimal point. So most of the time we're going to round to 2 places to the right of the decimal point. Occasionally we will round to the nearest whole dollar. Okay, now remember, in WebAssign you'll be told how much to round. And remember, when you do your rounding, it's always your final calculations, not any intermediate calculations. So we're going to look at some basic business functions in words and their corresponding formulas. Cost function, C of x. C standing for cost, and x is the number of items you've produced, whatever it is you're making, tape recorders, CDs, whatever. So the cost function is the cost producing x units of a product. Okay, the cost function normally consists of 2 parts. The variable cost. It's the cost of producing one item. It's sometimes called the change in production. It usually involves labor and material. So the variable cost always multiplies the number of units that are produced. Fixed cost or overhead. It does not depend on how many units are produced. It usually involves rent and utilities, things you have to pay even if you're not doing anything. For instance, if you're not making any products, you don't have to pay your workers because they're not coming in to work, but you still have to pay the rent on your factory. The cost function is the variable cost plus the fixed cost. Remember, the variable cost always multiplies x. It always multiplies the number of units you're producing. So C of x is equal to mx plus b. Notice this looks like a linear function with slope and y-intercept. So what we think of as the slope, that's the variable cost. Again, it's sometimes called the change in cost. X is the number of units you produced, and b is the fixed cost or overhead. It's kind of like, what does it cost you to do absolutely nothing? So notice, it costs you money to do nothing. The revenue function, R of x. Now again, notice these are capital letters. So the revenue function is the income or revenue from selling products. Revenue is price per item times the number of items you sold. It's like if you're selling purses for $12 and you've sold 2 of them, your revenue is 2 times 12. So R of x is little p times x, where p is the price per item and x is the number of items sold. Okay, notice it's an incredibly simple function. Now, the price per item sometimes is called the unit price. The profit function, capital P of x. Remember, little p is price, capital P is profit. Okay, the profit function is the profit or money made from producing and selling items. Now, in order to actually make a profit, the profit function, the P of x, needs to be positive. That means you're making money. If the profit function is negative, that means you're losing money. Like if it's negative 10,000, that means you're losing $10,000. If it's 0, that's the break-even point. It means you're neither making money nor losing money. So sometimes if you're being asked to find the break-even point, that's when you find where the profit function, capital P of x, is equal to 0. So break-even point is where P of x is equal to 0. So the profit function is revenue from selling minus the cost. How much did you make minus how much did it cost you to make that much money? Remember, we already have expressions for the revenue function and the cost function. So P of x is R of x minus C of x. Okay, that's what revenue always is. What profit always is. How much you made minus how much did it cost you to make that. Now, depending upon the actual numbers involved in R of x and C of x, there may be a little bit of arithmetic in order to simplify the way the profit function looks. Remember, profit is always revenue minus cost. If the profit is positive, you're making money. If profit is negative, you're losing money. If the profit is 0, that's the break-even point. You're not making money, but you're not losing money either. You're kind of just spinning your wheels, doing nothing. Number 4, the net profit function, capital N of X. Okay, oftentimes a business venture requires an investment. It's like, I need $10,000 to get my business going. The initial investments must be subtracted from any profits made in order to determine the net profit. So the net profit is equal to the profit minus the initial investment. Okay, now again, the profit is going to be the profit per item times the number of items that you're actually selling and making, minus the initial investment. Okay? Now, a lot of times these things, they're going to be given to you. You're going to be told, $10,000 is initially invested. You're going to make a profit of $15 per item. And the number of items is usually the variable. It's usually the X. Now, the above list of these 4 things that we did is not meant to be exhaustive or all-inclusive. There may be other word functions that require us to think our way through them. Okay? This is more than just imitate what you've seen. Okay, some examples. Gasoline-powered turtleneck sweaters sell for $99.98. The company that makes the sweaters has fixed cost of $5,000 per month and variable cost of $8.59 per sweater. Find the following. Simplify your answers. Okay, in part A, you're going to find the cost function C of X for producing X sweaters. Okay, now all this is per month since we're given the fixed cost per month. The revenue function R of X from the sale of X sweaters. Part C, the profit function P of X from the manufacture and sale of X sweaters. Part D, the profit from the manufacture and selling of 1,000 sweaters in 1 month. And in Part E, we're supposed to interpret the answer to Part D. The interpretation kind of being, did you make money, did you lose money? Now remember, if this were like a WebAssign problem, this would be what, 5 points? 1, 2, 3, 4, 5, yeah. So our solutions. Okay, we're supposed to, in part A, find the cost function. Okay, remember, it's the MX plus B, the variable cost of $8.59 and our fixed cost of $5,000. Okay, so it's your MX plus B. Okay, the revenue function. Okay, remember, the revenue is what's it selling them for, $99.98, times number you sell, which is X. So our capital R of X is 99.98X. Okay, part C, the profit function, where the profit function is the revenue minus the cost. So 99.98 minus the quantity of 8.59x plus 5,000. We need this cost function in parentheses. Remember, that's the entire cost function. Now, we can actually work on this by doing what's called combined similar terms. So 99.98x minus 8.59x. We're going to get the 91.39, I lost my x, plus 5,000. So there should be an x there. Okay, so put an x there. See, question D, the profit from the manufacture and selling of 1,000 sweaters in 1 month. So again, there's supposed to be an X there. So for part D, we're actually looking for P of 1,000. Okay, that's what you're looking for in part D, P of 1,000. So you're going to have 91.39 times 1,000 minus 5,000. You just do your arithmetic. You get 91,390 minus 5,000. So 86,390. Okay, and of course this is dollars. Now remember, in WebAssign, the dollar symbol will be there. And again, don't forget, in part C, there's supposed to be an X sitting next to that 91.39. And see, part E, the interpretation of part D. Now remember, part D was 86,390. It is positive. So, our interpretation, since the result is positive, that means we had a profit from the sale and manufacture of 1,000 units of $86,390. So we made money. That's what we're going to have to pay taxes on. Now again, remember, if the profit had been negative, that would have been a loss, and we were losing money. And that's actually your write-off. If it had been 0, that says you're breaking even. Okay, if it had been 0, you're breaking even, you're neither making money nor losing money. But since we were positive, we made $86,390. Example 2. Useless Products Incorporated has invested $35,000 into the development of solar-powered clothes dryers. The company expects the profit from each solar-powered clothes dryer to be $70. Find the net profit from the sale of X units. Find the net profit from the sale of 800 clothes dryers. Notice this is 2 questions, so this is actually a 2-point question. So our solution. Remember, the net profit is equal to the profit per item times the number of items minus the initial investment. Okay, the profit per item, we're expecting $70. Okay, the number of items, we're selling X of them. The initial investment, $35,000. So N of X should be 70X minus $35,000. There's your net profit function. The second question was to find the net profit from the sale of 800 clothes dryers. So that means we want N of 800. So we're going to have 70 times 800 minus 35,000. So we got 56,000 minus 35,000, which is $21,000. So notice we are making money. Our net profit is we are making money. So it's kind of like we paid off the guy that gave us the initial investment. Question number 3. To determine the total variable cost for producing an item, a company must look at the cost of material for making the product and the labor cost for assembling the item. That's usually what goes into variable cost, which, remember, in terms of the language of a linear function, that's the slope. So the company has determined that it takes 3 employees working together 25 minutes to assemble the product. Each employee is paid $12.25 per hour. The cost of the material to make the item is $500. So find the variable cost to make one item. Round your final answer to the nearest whole cent. Our solution. Okay, now the variable cost is the labor cost plus the material cost. Okay, labor cost plus material cost. Now for the labor cost, we're told it takes 3 people 25 minutes to assemble the product, and each one is paid $12.25 per hour. Notice it's per hour, not per minute. So the number of employees times the hourly rate times the number of hours. Okay, that's what we're going to be doing to figure out labor cost. Number of employees times the hourly rate times the number of hours. See, there are 3 employees. Okay, the hourly rate is $12.25. Okay, the number of hours. Remember, there are 60 minutes in an hour. So 25 minutes is 25 over 60th hours. So 3 times 12.25 times 25 over 60. When you do that multiplication, you get 15.3125. Okay, so there's your labor cost. The material cost. Okay, we're told the material cost $500. So there's no calculation to do. It's right there, $500. So the variable cost, the labor cost plus material cost, rounding to the nearest whole cent, $515.31. Really kind of high when you think about it, but sometimes to manufacture a car, the variable cost is incredibly high. Proportions. Usually it's stated as ratios and proportions. You cannot do proportions without ratios. So definition. To say that y is proportional to x, or that y varies directly as x, means that there exists a non-zero constant k such that y is equal to k times x. Notice the equation is incredibly simple. The trilogy notation for all this, proportional and varies directly. Number one, the equation y equals k times x is called the variation equation or equation of proportionality. Again, notice it's incredibly simple. The constant k is called the variation constant or constant of proportionality. Okay, now, depending upon the actual physical situation, k does in fact have honest-to-God names. Like sometimes in aerodynamics, it's called the drag coefficient. In building materials, when you're testing the strength of materials, it's sometimes referred to as Young's modulus. So depending upon the physical problem, it does in fact have names. And most of the time, like in construction, Young's modulus is in a table, a book that has extensive tables depending upon the material that's being used. So you don't usually have to figure it out. It's something you look up. So if y proportional to x, we sometimes write this. Okay, what looks like someone chopped off part of the infinity symbol, and it's read y is proportional to x. Okay, now, depending upon the actual problem, again, k can have a special name. The most common names involve the word rate. As an example, if you're an hourly worker, then your pay is proportional to your hours worked. And the value of k is your hourly rate of pay. Like the more hours you work, the more you make. And again, that should say your pay, not you pay. Let's look at some examples. Number one says, the distance d traveled by a car is directly proportional to the amount of gas A used by the car. If the car can travel 138 miles on 5 gallons of gas, answer the following. Question A, what is the variation constant? Answer to the nearest tenth. So that's 1 decimal place. Question B, what is the variation equation? Now notice you cannot write the variation equation without figuring out the variation constant. And question C, is there a common name or notation for the variation constant? If so, what is it? Some of you may already figured out the answer is C without even doing parts A and B. So our solutions. Okay, again, this first sentence, the distance d traveled by a car is directly proportional to the amount of gas A used. That first sentence is telling you d is equal to k times A. That's all the first sentence says. So usually in the variation equations, they all start out this way. The first sentence tells you this. It just basically fills in different letters for y equals k times x. Okay, we want to find k. Got to find k. Now notice we are given a value for a and a value for d. D is 138 whenever a is 5. So I know that 138 is equal to k times 5, or 138 is 5k. To figure out what k is, divide by 5. So when I have 138 over 5 is equal to k, and we're supposed to round to the nearest tenth if necessary. Okay, it works out to be exact. It's 27.6. So k is 27.6. So there's your variation constant, 27.6. For part B, what is the variation equation? I just replaced this k right there in this equation with 27.6. So the variation equation, B, d is equal to 27.6a. Okay. Notice the real work is an A. Okay, part C, is there a common name or notation for the variation constant? If so, what is it? It's usually referred to as your mileage, your MPG, your miles per gallon. So it's sometimes called gas mileage or just simply mileage. So the variation constant is commonly called gas mileage or MPG. And notice, you're getting 27.6 miles to the gallon, which is pretty good, I guess. Example number 2. The total weight W of a certain solid varies directly as its volume V. A certain sample of the solid has a weight of 300 pounds and a volume of 15 cubic feet. Find the following. In part A, the variation constant. In part B, the variation equation. Part C, is there a common name for the variation constant? If so, what is it? In part D, find the weight of a sample that has a volume of 20 cubic feet. And of course, A and B are related. You cannot get the variation equation without the variation constant. So our solutions. Okay, in part A, again, the first sentence, W varies directly as V, W is equal to K times V. Okay, that's all the first sentence says, W is equal to K times V. We, once again, have to find K. Now, we have some values for W and V, don't we? Let's see. Weight is 300, volume is 15. So 300 is equal to 15K. To figure out what K is, just divide by 15, right? So 20 is K. Okay, to get part B, replace this K with 20. So W is equal to 20V. That's your variation equation. Okay, depending upon your experience with science, if you're looking at, think about what we did here. We took the weight divided by the volume. That's density. That's density. So the value of 20 for K says that the density is 20 pounds per cubic foot. And D, find the weight of a sample that has a volume of 20 cubic feet. So we're going to let V be 20 in our variation equation, which is in part B, and figure out W. So W is going to be 20 times 20. Was that 400 pounds? And that's the end of section 1.4. That's the end of chapter 1. Now remember, our first test covers chapters P and 1, so it's also the end of the material for test 1.